Rika Kobayashi. So she's going to talk about where's Wally finding the next generation of scientific programmers. Okay, let's welcome Rika Kobayashi.
And I should warn people later that I am going to be sharing video, sound through Zoom. So if you don't have your headsets, there might be some that you'll miss out and it might not make sense. So you might be prepared to have to put on your headsets later. I'll tell you when. But anyway, that looks okay. Yep. Oh, let me get this out the way. Yep, okay. So thank you for inviting me here. I'm still on camera, yep. So the origins of my talk today actually go back 2 years to the 2020 edition of the conference series, which you can still follow from the YouTube videos that are there. And I still watch those videos actually, but spurred on by the theme of software modularity to help create an ecosystem which will make program development easier and more sustainable. I was distracted in the time of COVID to change my talk to other tools for collaborating virtually. I haven't practiced my slide changes actually. And gave a talk instead on technological advances in virtual collaborations. But actually in that talk, I mentioned that my original intention, reflecting on my life as a programmer from coupled cluster theory to density functional theory, and how unrewarding that had been, was to talk about how a significant factor in making scientific software sustainable must surely be people. Many of my colleagues, generation who followed a programming career track like me, they've actually left the field, unable to get jobs. In my previous role as scientific and technical advisor at the Australia's National Supercomputer Facility, we're sort of seeing a huge decline in groups actually developing their own software. I often field complaints from researchers, and Dan, you must get this a lot, with people complaining that their research has been stopped because no one's programmed up the latest new thing into their program of choice. And finding a scientific programmer is really getting far harder than finding Wally. So 2 years later than planned, this is my talk for today. Finding the next generation of scientific programmers. And there have been a few interesting developments that have happened in between. But going back to 2020, my favorite talk of NHISS 2020, apart from my own, of course, was given by the programming survivor, Roland Lind, entitled Strategies for the Open Molcast Legacy Codes, 50 Shades of Fortran and some more. And hopefully Valera will tell us more about it in this conference series. But in it, he gave a rundown of all the programming languages he had learned and forgotten during his long career as a Molcast developer, leaving Fortran as the only one that had lodged in his brain. And the reasons he gave were that Fortran, now my computer's playing up. It is consistent. This is very slow. I see what you mean, Roger. It builds on top of what was before. It can be easily propped up to use accelerators without writing new code. And he went on to say that Fortran is the language most adaptable to change, referencing Charles Darwin. And this view is also shared by Dr. Damien Rousson of Lawrence Berkeley National Laboratory in his great little talk, Why Fortran Persists. And Damien actually attributes his advocacy for Fortran as being part of a minority group himself. He's a Black American computer programmer, that he likes to champion the underdog. Or is it? So we haven't been able, or actually Damien hasn't been able to get more recent statistics, but back in 2015, close to 60% of the codes being used at NERSC were written in Fortran, with C++ and C following closely. If you actually weight those codes by the time used, its importance would be even greater. And there are others that would agree. However, this talk isn't going to be all about Fortran. It's not even going to be about what computer language we should be teaching, but it has everything to do with whether we should be teaching programming at all. Spoiler alert, yes, and how we should be teaching it. And I actually expanded on this in the proceedings of that conference series, where I pulled out some statistics. So when I last looked at this, the numbers in 2019, Tech Republic claimed that in the tech industry, there were 17% more job openings than available workers. And 70% of executives said that the current employees lacked the technical or computer skills that were needed. Furthermore, Scientific American went on to say that the shortage of software engineers was expected to reach 1 million by the year 2024. So how are the various countries addressing this crisis? Well, in my own country, Australia, the government implemented the Coding Across the Curriculum program, and in it had the aim of supporting teachers to provide students across various year levels the opportunity to learn about algorithmic thinking, computational thinking, and coding. In the United States, President Obama introduced the CS for All initiative with a $4 billion budget to empower all Americans to be equipped from kindergarten through high school all American students from kindergarten through high school to learn computer science and be equipped with the computational thinking skills they need to be creators in the digital economy, not just consumers, and to be active citizens in our technology-driven world. The only problem was that it didn't get funded. But actually, if you look at it, it still does exist, but in an unfunded community of practice sort of way. In Europe, the European Commission produced a digital education at schools in Europe report, which looked at all aspects of digital literacy at schools in Europe. And among its findings and recommendations concerning programming or coding, said while less than half of the European education systems explicitly include this competence in terms of learning outcomes in primary education, around 30 countries do so in lower and upper secondary education. And I think of all the countries I actually looked at, Europe seemed to be doing the best regarding computer education. I did try and look at the situation in Asia, but the trouble is that I think because these are really national issues and I was searching in English, I don't think I got a good picture of it. However, there is another caveat coming up here. Most of these initiatives concern the tech and IT sector and target languages such as JavaScript, Java, and Python, as confirmed by Tech Republic again. And did I say that close to 50% of the languages used at NERSC were sort of attributed to Fortran, closely followed by C++ or C? But this is also not totally irrelevant to scientific programming, because a lot of the students I'm encountering, especially in Australia, are coming from a hugely data science focused background, and discouragingly are reluctant to pick on a harder language with a view of leaving the field later. And encouragingly though, I am also coming across many computational chemistry students who do want to sort of like do method development, and they do want to see their ideas put into code. And also, yeah, Python is not exactly a bad language to start teaching basic programming concepts for. So that was 2 years ago. What has changed since? A lot, as it happens, and these are my own personal experiences. I'd really love to hear your own sort of like perspectives later on, especially when we have this global audience. But as far as I can see, there appears to be a worldwide push for working from home. I don't know what this is going to mean in the long run. I am seeing more virtual initiatives, not just meetings and conferences, but training as well. And seemingly an explosion of online Fortran courses. So when I started looking at this seriously 2 years ago, I could actually only find 1 or 2 online Fortran courses. And in fact, being part of the user support of the Supercomputer Center, I had been looking at this space for decades because we're frequently getting requests for people to offer programming courses and training and stuff. 2 years ago, 1 or 2. Now there are many, both paid and free. For example, first off the Google Cab Rank, Udemy, Tutorials Point, Learn Fortran. However, many of the more established courses for that you see online, like for Java and Python, they actually have tutors and discussion forums. They're more sort of like mature. A lot of these Fortran courses just seems to be sort of like static material, just resources, videos and PDFs with very little interactivity. And in fact, the Learn Fortran site was even more interesting because it provided a list of links to online existing courses. And then I realized that these courses already existed. They've been there for a while because we'd actually even referred students to them in the past. The only difference being is that since COVID has made online education more marketable, people have been making them more visible. So I was fully involved with HPC training at the supercomputer facility until 2015 and partially until 2020. And I had been sort of like really up to date with the online offerings for courses and resources. I can say that it really is in the past couple of years where I've been sort of seeing a lot of activity going on in this space. And in view of the audience here, I'll also mention education at Mulsi. And confession time, I haven't actually really looked much into the material, but I think I'm definitely putting it here as an example of the resources that places like Mulsi, and in fact my own institution, NCI, are putting in since COVID struck to try and address this problem. And another special mention for NVIDIA Developer Central, which I've been following on for decades, so it is not new. And it isn't really a programming course, at least it wasn't initially. It was always, well, it started off as being trying to teach people best practice for using GPUs. But I have been learning so much from the workshops and webinars that I would class it as a really good learning resource. And it is still really very early days to see how much of an impact all these online courses are making. But such courses are definitely needed. And I can say this because I have been part of the virtual Winter School on Computational Chemistry Organizing Committee for a few years now. Next edition, 6th to 10th of February, if anyone's interested. And this year, following on from the momentum of all the online events that COVID had triggered, and also because I'd been given a year of sponsorship for my GatherTown, we decided to hold a special one-day event focusing on computational chemists in Africa. Being virtual, it means that there aren't any costs, so we can try and do something experimental. And usually when you had these events focusing on Africa, it used to bring a global community of researchers to an African setting. But for this, we wanted to actually hear from Africans. So let the actual Africans sort of showcase Africa to the rest of the world. And it was an eye-opener. We heard from people one normally doesn't get to hear from, and it was fascinating and refreshing to hear their new perspectives. But the thing that hit home most for me was we met so many students, talented students, who had ideas for method development, and they were actually teaching themselves programming and finding it to be an uphill battle. And so this talk is actually dedicated to them. So I definitely believe there is a need to provide education support to the next generation of programmers. So that answers why teach programming. For the rest of my talk, I'm going to talk about how to teach it. But my day job is neither in teaching, nor is it in fact in event management. Those other people seem not to think so. So I haven't really looked deeply into the research into software education. This following is actually from my own personal perspective as a practitioner, and I have spent a lot of my life dabbling in teaching both in person and virtually. So one thing I've always believed is that learning should be active. And I think most of those online courses, mostly the Fortran ones, are one way without the students having much opportunity to interact. And as I said, at least some of the better Python courses, they provide discussion forums, if not tutors. So for a long time, I have been looking into more interactive, collaborative ways of teaching online and discovered GatherTown, which started life as a video calling platform, but was quickly embraced by conference organizers to add a bit of a more social aspect to meetings. However, I found its use of spatial audio, private spaces, and embeddable objects very powerful. And for the previous NHISS 2020 conference, I mocked up a computer lab where we could collaboratively live code Python, starting from a research paper on rotational spectra, a whiteboard where I could write equations very slowly, together with colleagues, while talking to them at the same time. Yep, there they go. And I could take this equation into a computer with a Python notebook embedded in it, and we could code together all at the same time, all in the same platform. And as I said, I just did in NHISS 2020 for fun, but then someone on the Software Carpentry Slack asked for advice on how best to deliver online Python programming workshops. And I said, why don't you try my Gather Computer Lab? And they did. More fools them. As part of the 2022 Software Sustainability Institute Research Software Bootcamp. And we've actually written up our experience here. We had as an instructor, Sarah Jaffa, who's one of the co-authors of my talk, and also 7 helpers, including my other co-author, Jeremy Cohen. And in fact, Roger pitched in too as one of the helpers. And this is how it went. But first, a little bit about the Carpentries. So the Carpentries project, consisting of the software carpentry, the data carpentry, library carpentry, are a global community with a shared goal of teaching foundational coding and data science skills to researchers worldwide. It has been going on for about a decade, though its origins began much earlier in 1998, starting from a training course in the US national laboratories to improve researchers' computing skills. Now, within the community, they offer training and they provide courses to be delivered. And we actually used the software carpentries material for the course that we ran. Now, the current content is basically Unix, Python, R, and MATLAB. But since COVID, a lot of special interest groups have been springing up. And for example, there is now a computational chemistry and cheminformatics channel. So there is scope of expansion, but I really haven't seen much activity on it yet. Now, one thing that distinguishes the Carpentries workshops from many courses, especially online ones, is their emphasis on live coding, which I approve of very, very much. I value the student-teacher interaction in the teaching process. I love the way that you learn from the students asking questions and talking to them back. And this is exactly what GatherTown lets us do. So basically, here is my computer lab with 60 desktops, and it's actually open and available right now for you. If anyone wants to see it, let me know. I'll send you the link and you can go in and play. So we have desks grouped in private spaces of 2 and 3, which means that the students can talk to their nearest neighbors. That is peer coding in action. We have a little private space where the tutors can hang out and talk to each other while they're not roaming the room. A lectern that is spotlit to the rest of the room so that the speaker can talk to the rest of the room, a whiteboard, and each of these actual computers are connected to a Jupyter notebook. And for this course, we made use of Google Colab. But the trouble with Google Colab is it couldn't embed, so we had to open up our workbooks in the tab. But that's no worse than what other people who are trying to do this stuff are doing at the moment. And also, being in Google Colab, it means that we can share data through Google Drive, which makes it even more convenient. You don't have to get people downloading data left, right, and center and losing it on their computer. And it is just a regular notebook, which can run interactively. And each student has their own individual notebook, and the tutors can actually look at those notebooks either directly through Google Colab or over their shoulder using screen share. And they can do all that without disrupting the other people in the class. So unlike Zoom, where communication is one to many, You can have many many conversations all occurring simultaneously. And better than breakout rooms, which I really hate, even though the set of desks that I showed you have broken out, everyone actually stays in the same room, so you can see what is happening elsewhere in the room, and no one feels like you're actually missing out, which is what I hate about breakout rooms. You just think that everyone else is having more fun in the other one. And sorry. Oh, right. Nope, that's not it. That's just rewinding it. Damn it. Try that. And this footage from the actual day, so if you want to hear it, you're going to have to put your headphones on. I actually really like because it highlights one of the things that worked really well in Gathertown. So this is Sarah coming back from the break.
Teaching now, so I'll just get my screen to the right bit.
Can people hear that?
So if you, just to check everybody's back, can you give me a thumbs up when you are in your seat and ready to continue, just to check people haven't wandered off to have a break?
So you can see the thumbs up.
Okay, I can see at least half of you are here. That's good. Okay, I'll share my screen again. Oh, I've got very hot tea and now it's too hot to drink. Here we go, sharing this window. So our next section is making choices. So how can you make a program do different things depending on data values or inputs?
And she was actually doing this throughout the course. She'd stop and ask the people if they were sort of like thumbs up, if they're happy, or question marks, if they were sort of like a bit confused. So if there were lots of question marks, she'd repeat the material. If there were only a few, one of the thumbs ups, if there were only a few question marks, one of the tutors would go and talk to them one-on-one without disrupting the class. And actually one of the students commented on the fact that they liked the way that they could ask for help without holding up the class or having the spotlight sort of focused on them. So that was my bit of fun for the year. What about the future? So to end with, here are a few of my thoughts for the future. I think we will see more global collaborations. COVID forced people to look further than their immediate surroundings, and many found opportunities opening up for them. But we will need to have the infrastructure in place to make this work, not just collaborative platforms that we've been talking about, but people and people supporting people, sorry. There is a danger that once the novelty wears off, people will decide that they want to go back to normal. But even before COVID, there were signs that initiatives such as the carpentries and online education were really building to something. So should we be putting more of an effort into something like this? Should we be joining the carpentries? Maybe we should be piggybacking Molsey or even Edison, because you're all wanting to have education is built into your platform. Education, sure, you're there, but I am not seeing programming education in there yet. And just recently through the Winter School Grapevine, because we talked to CCAM and Marvel a lot, they themselves are actually looking into this space. One for John. Legacy codes are at a cusp. Are they going to thrive or even survive? And looking further into the future, mainly because a lot of you might be overwhelmed that technology is just moving too fast. And because I seem to have been attending far more workshops in virtual reality recently than I have in reality, we don't need to jump on the metaverse bandwagon just yet. It's not ready for us. Thank you.
Okay, thank you. Any question from audience? Okay, Professor Youngmin Lee.
totally agree. I have no idea because I'm having trouble linking students from Python to Python. And the reason why I say this is that I did a teaching degree, and the thing that actually hit home most is context. So I did some second year Python programming teaching at the Research School of Chemistry. And this is why I looked at all these online courses and found out that they weren't actually appropriate. So I ended up writing my own from scratch. So I taught quantum mechanics and thermodynamics, and I just rewrote the whole Python course and actually tailored it. So context is everything. And the reason why I said the data focused background was terrible was that all these people who'd actually done Python at school were learning lists, and they were trying to do all these sort of like numeric equations using lists. And I had to put in NumPy lecture 2. If you look at online courses, NumPy don't even turn up in half of the online courses. And I was introducing NumPy in 2, and they were all trying to do all these solving equations using lists. I had to get them to unlearn lists just to use NumPy. So yes, I don't think I know how I'm going to get someone to teach to learn Fortran, but still they'll get some various ideas like variables, arrays, something. But yes, I'm a bit worried about that, but they're not going to. It's better to start teaching them something like Python than actually trying to force them to learn something hard, because they'll think that's not going to get me a job in, latest tech sector thing. Yes, very good point, but that's what reality is.
Okay, Elfie, please.
Okay.
Especially in the United States, show. So, how is your experience?
I absolutely agree. No, I mean, if I'm always getting in trouble with chemistry departments because they keep dumbing things down and we're getting less and less maths. Yes, I am seeing Australia actually suddenly realizing that you can't just ignore maths, and they're starting. I think it's something that they've learned the lesson the hard way. I am thinking that maths is going to sort of like make a resurrection, because it is very, very much needed. And you're right. I mean, I've got so many people who sort of think, oh, I can do Python, I'm now going to program up something very difficult, and they don't even understand the theory, let alone the maths. So yes, bring back maths. John.
Seen any significant, basically I asked him, were the Gen Chem students better at algebra when your career started in the early 1970s than they are now? Probably about 10 years ago. His answer was no. So I'm not entirely convinced that our students are getting less good at math.
It might be your students. You come to Australia.
What I do think is an issue, and I talked about this with Peter Gill, for example, is that in his generation and mine, if you were a person that sort of liked physical science, also liked messing around with computers, quantum chemistry was kind of a very natural career avenue for you, because computer science really didn't exist, certainly not in Peter's generation. Kind of came into existence as I was going to college, and now, there are just so many more job options for those people, so many more career avenues, that I'm concerned that the people with programming interests will just go program science. More than defining math skills.
I don't know, but You're a programmer, don't you? Because I work at a supercomputer center in a support role. So we're always getting people saying, can you program? And in fact, they have been. So, you know, there's a lot of the stuff that I've been programming up hasn't followed my own research. It's been following up people saying, please program this for me, or please teach my student to program this for me and stuff like that. So I think it's very much a need from where I'm standing.
Okay, let's finish here. So to the time limit, so we close this. I mean, okay, let's thank the Professor Rika Kobayashi. And our